it's something that you could look back at. I mean, I know you're sitting here saying, well, I'm here. Awesome. I love that you're here. But you honestly, you could look back at this if you want to, especially as we get going through the year. Maybe there'll be something you need to kind of hear it again. So we're going to look at lesson 1, 2. Okay, we're in this chapter 1, which is kind of like all the math that you were supposed to have learned or did learn up to this point. Remember, there's always going to be some things that you might look at and be like, oh yeah, or I don't really remember that. And that's why I'm going over it. I'm usually going over some of the items that kids have more trouble with. Now, functions. That's kind of a big word. I mean, most things in math are functions. The authors of the textbook decided to use this opportunity to talk about more basic ideas about functions, which you're going to find out that I'm going to do with you here. Domain and range. I don't even want to say, do you remember them? I know you remember domain and range. Listen, it's not like domain and range is that necessary evil, that we have to get through. It's supposed to get you to think about equations. It's supposed to get you to think about numbers. It's supposed to get you to think about what it is that something as simple as y equals x squared is saying. And you actually had to think about some of this stuff when you were doing your parametric homework. Of course, I started in the middle of the chapter, so there was already stuff in there that kind of goes back to this. But when we say something like y equals x squared, okay, and we want to talk about the domain, I always like to use this opportunity to make sure you remember that's simply asking what x values can you square? Like in its simplest form, the domain are x values for this equation. What x values can you square? And you should be thinking to yourself, can I square positive ones? Yes. Can I square negative numbers? Yes. How about 0? So it looks like every number is allowed to be plugged in here because every number can be squared. And that's why the domain is all real numbers. Now it's supposed to be kind of easy, but you can use that thinking for harder problems. What numbers am I allowed to use? Now the range, yes, I know, it's the y values, but in this case, it's like asking what kinds of results, what kind of output, what type of numbers do you get when you square something? So if you square a positive number, if you square a negative number, well, of course, you're always going to get positive. Now, you could also get 0, so you need to be careful about that. But technically, the range is restricted by the square. And so the range has to be stuff that's positive or 0. Now, actually, the range in general is harder to do because you're kind of thinking about what would happen in 2 steps, plugging in, and then you're thinking about the square. This one was easy because we all know what happens when you square something. Sometimes the graph can be helpful to understand the range. And again, try not to be like, okay, I've seen this, done this, but sometimes kids, they're still having trouble picturing this. These are y values. And the only y values that this graph contains, the only y values that it contains are y values that are greater than or equal to 0. Okay, so you want to look at the graph separately with its x and y values. One over 1 minus x squared. 1 over 1 minus x squared. All right, so it's no longer y equals x squared anymore. It's no longer just kind of basic, but there should be some knowledge we have about fractions. Fractions particularly when we look at their denominator, have some no-nos, right? What's true about the what's true about the denominator of a fraction? It's never allowed to equal 0. Okay, now if the denominator is never allowed to equal 0, we can use that statement to start to think about x. I mean, honestly, to solve for x. Now, follow me here. This domain is actually going to be the numbers that are not allowed. We're going to describe the domain by actually saying that, well, when you solve this, here, let's just kind of solve it first. When you solve this, I don't want to make a big deal out of it, but be careful, okay? You get x squared equals 1. I mean, you got to move some negatives around and all that, but you get x squared equals 1. You're solving this. And a little detail item, whenever you take the square root of a number, when solving an equation, always produces a plus or minus. So we end up getting x, well, not equal. We end up getting x not equal to plus or minus 1. And so let's turn that into a domain. Let's say that means that the domain would be all x values such that, now I'm getting into some like set notation here. So the domain is all x such that they just can't equal plus or minus 1. And we close our little curly brace. Okay, but that all started with the denominator. And if you're like, is it always that way? Yeah, every fraction, the denominator can't equal 0. And that'll get you a place to start thinking about the domain. The range is a little harder. Here's kind of the truth. You'd have to start thinking about what happens if you plug in any x value that's not equal to plus minus 1. So, I mean, you'd have to plug in 0, 2, 3, 100, negative 100. Okay, and as you start to plug those numbers in, you would get y values. I don't see anybody getting like real excited about that. A graph shows those y values. I find that sometimes we've gotten so deep into math, which is great, but you kind of forget about, the basics, which in this case, when you see a graph, it is the x and y values. Okay, and that's kind of like what I'm trying to talk about here. Now, something else about your about your calculator, and it's always kind of up to you. I mean, I always suggest that you play along. If I wheel this dinosaur out here, it's probably a good idea for you to also do the same, but it's always up to you. What's the last thing you did on your calculator? The last thing I did on my calculator was one of those scatter plots about the population of the world. Remember that problem? Maybe the last thing you did on the calculator was a parametric something. So, like, is your mode right? Okay, we're kind of back to functions. So, make sure your calculator is in function mode. That way, when you go to the y equals screen, it's actually y equals. Now, there's something else, just trying to get you guys comfortable with the calculator. Some people have different comfort level. If that's highlighted, or for that matter, if any of that stuff's highlighted, that's like a scatter plot. That's like the calculator is going to try to look at your list of data in L1 and L2, and it's going to try to do a scatter plot. We don't want to do that. And sometimes that just causes errors and confusion. So turn off. Now, I just did something there. It's a little trick. Highlight and hit enter. Highlight and hit enter. Turn off the scatter plot. Be a good math student and make sure you put parentheses around the numerator and or denominator. and some of your calculators kind of help you with that a little more, but put parentheses around numerator, denominator. Other stuff, it's just true, and I want you guys to understand your calculator. The window, what's your window? It might be from something yesterday, last week, okay? If you hit zoom standard, it's usually kind of a quick way to get things back to normal numbers, back to 10 and negative 10. Zoom standard makes your window go back to a pretty normal situation. Now, sitting in this class does not mean that you understand everything. That is fine. I'm glad you're here. But it does mean that you've seen a lot of things, and there should be some stuff even by this graph that kind of rings some bells. Rings some bells. Ding, 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 ding. Like, what's going on with this graph? Is there any, I interpreted the graph, but there's some more going on here. Okay, there's a certain feature, there's a certain thing. You have to be careful how you say it. A vertical asymptote. A vertical asymptote. And remember, there was a song that was sung about vertical asymptotes, right? There was a song. Okay, this dude had on like these big baggy pants, and he sang this song. It kind of had the same lyrics. It went over and over. It went, "You can't touch this." And then there was like a "there. You can't touch this. You can't touch this." And then there were some other lyrics too, like "break it down" or something. Vertical asymptote. And any guesses where? Now, I kind of asked Nate any guesses because, maybe it's just kind of a guess. You're kind of looking at it. Maybe, you sort of seen something like this before. It looks like the branch is creeping closer. And you're right. Okay. There's a mathematical way to know that it was y equals 0. But just for starters, it's there. There's a horizontal asymptote. So we just want to sort of just say, yes, it's there. Now, what are we doing here? Oh, we're trying to come up with the range. Okay, the range. The range is the y values. Okay, now when you look at the graph with its y values, the truth is these vertical asymptotes don't relate because those relate to the domain. Make sure that you've processed that the vertical asymptotes we kind of already found because the vertical asymptotes are the domain. So the range is more like the y values. Okay, now Nate gave us a y value that you can't touch. Do you agree that the graph is below? The graph is below 0. Okay, that's part of the range. Now, if you're below 0, you're negative infinity to 0. But that's not the whole story, right? Because there's a little more about the range. You're also above. You're above. Now, if you still have your calculator on, look at it. What y value do you see there? It's not trying to trick you. I mean, if it's an application problem, maybe it's going to be some decimal, but that y value is 1. And so you should say that you're above 1. Question, can you equal 1? Can you equal it? One way to find out would be to trace. And if you trace, at least on my calculator, it just so happens that that's where I start. So look, I'm at 1. I have an x value. That's code for you can be at that point. That point exists. You 1 with a equals sign. 1 with a bracket. So the question was, can I be at that point? Can I be at 1? Yeah, you can be there. Look, we did the range with the calculator, and there's going to be many times this year where we do stuff without a calculator, and then there'll be things we do with the calculator. You kind of have to play along. As I said, maybe the first, second day, don't be the calculator kid. The calculator kid tries to do everything on the calculator. Okay? I want you to be both. Okay? So you're like, well, so what do I do on the assignment? When you do the assignment, you should be thinking about the domain without your calculator. Okay? And I'm going to do another one, and we'll do the same thing. But basically, I'm kind of giving you license to use your calculator for the range. Now, this one was pretty easy. You're not even going to see something that easy. But you can use your calculator for the range, okay, because it's harder. Now, horizontal asymptotes, there are actually some rules. I'm not big on rules because kids forget them, but there are some rules, and there's going to be some rules in calculus this year. I'm referring to some rules that enable you to get the horizontal asymptote. Now listen, the horizontal asymptote was the one where Nate said y equals 0. But well, I won't say this every day because it won't happen every day. But from last year, there's some rules. Let's go over them because usually it brings back some thoughts, and for some reason you never heard it, you can still learn it today. It has to do with the degrees. The degree is the exponent that you see in the numerator or the denominator. The degrees. The degree in the numerator was x to the 0 because there was no x value. So the degree in the numerator was less than the degree in the denominator. And when that happens, when the degree in the numerator is less than the degree in the denominator, y equals 0. Y equals 0. It's kind of weird, but it's always y equals 0 when the top is smaller than the bottom. Now, if the degree in the numerator is equal to the degree of the denominator, if the degree of the numerator is equal, then we end up with the coefficients. And we normally call that a over b. But if you're like, whoa, what's a and b? That's the coefficients. Now, we can make up a little problem. Maybe you can just kind of listen. Because if the degree was going to be equal, it would have been something more like x squared over 1 minus x squared. Now the degrees are equal. The coefficients are a and b. And so, for example, my asymptote would be at 1 over negative 1. Negative 1. Okay, so you take the coefficients of your x. How about if the top is bigger? How about if the numerator is bigger? Anybody remember? It's just kind of a straight up, you remember, but the answer is Colton? It's not, but I'm trying to think like what that might have been. It's not that. It's all right. Just kind of threw it out there if anybody remembers. One more. Strike 3. It's known. None. Listen, there's not going to be much this year where, you hear me say last year, because most of this year is going to be new for everybody. Like when we get past chapter 1. But chapter 1's important. I don't want to make it sound like we're trying to get past it, because we have to know these math ideas. Besides, a lot of you take some kind of math placement exam, like for college. A lot of it goes back to these ideas, so it's good to refresh on this stuff. If you're still going to sit down and take an SAT, you know, it's more algebra. It's not going to be any calculus. Okay, that was a little bit of a pause just to talk about a horizontal asymptote, but like that's important because, you know, if you didn't just look at this graph and like Nate said y equals 0, then you might need to look at the numerator and denominator. If you look at the numerator and denominator, then you'll know where the asymptotes are. Let's look at another function. Okay, square root of 9 minus x squared. Careful. Does that kind of throw you guys off? Still throws me off. Okay, 5-minute warning. Careful. Sometimes kids will be like, wait a minute, I thought a square root was always plus or minus. That's not really true. A square root's not always plus or minus. What's true is if you take the square root, if you create a square root, the solutions are plus or minus. But not every square root has to be plus or minus. Here's the truth. This square root, by the way I wrote it, implies that it's only plus. Now, it's not really a big deal for this problem. I just kind of want to make sure you guys are aware of that algebra idea. If I wanted it to be minus, maybe I would have put a negative in front of it. So anyway, it's just the square root of 9 minus x squared. But let's find the domain. Domain. No calculator. Like when you finally take a test on this, this will be on the no calculator part of the test. Okay, so what do you know about square roots? Maybe I should ask, what do you know about what's under a square root? What's under a square root? Can you take the square root of a positive number? Yes. Square root of a negative number? Oh, how about the square root of 0? So what we need to do is we need to say that 9 minus x squared is only allowed to be or to 0. This sometimes kind of bothers kids. Like, I can just say that? Well, it's true. Whatever's under a square root has to be greater than or equal to 0. But look what we've done. We've made something that we can solve. Something we can solve. Okay? And kind of like I did for the other problem, you solve it. You know, you subtract 9. Okay? You solve it. By the way, the steps I'm showing, you know, you should show work on your assignment, but I could see that you could skip some steps. I would hope that you would show this step, x squared is greater than or equal to 9, because it would show that we have a little mistake. I have to admit, I didn't realize it, but we can always learn from mistakes. I actually made a little mistake. And thankfully, I showed my steps so we can see kind of like why. What happens when you divide by a negative? Divide by a negative? Yeah. Okay, little detail that we now have correct. So keep solving, and you get x. Of course, you're going to take the square root, right? So you get x is less than or equal to plus or minus 3. Now, this time I purposely made a little mistake. Just warning, because if you're using pen, we're going to change something. But you take the square root, you get plus or minus. Okay, now think about what this is saying. This is saying x can be less than 3. If x is less than 3, it goes that way. But then it's saying that x can be less than negative 3. Okay, you should kind of feel like, wait a minute, I thought this was supposed to be like an inequality. It's sort of like, you know, like a number line, with 3 and -3. What's going on here? We're less than 3, but then we're less than -3. Okay, what's going on here is that, how can I say this? When you get a negative, you also switch the sign. Now, I switched the sign from a less than to a greater than, but I got a negative. This is the way you have to do inequalities with a square root. Okay, now I imagine you might be like, how am I supposed to know that? Okay, and the answer is thinking about the graph that I was creating doesn't make sense. It doesn't make sense because it needs to stop at -3. It needs to stop at -3, or else I'm going to get a negative number. Because if I get something like -10 and start plugging that in, I'm going to get a... All right, let's continue on with functions. Maybe a little more emphasis on the fun part. Try to make it as fun as we can. Now, we kind of basically, the idea behind this domain, because look, if you're going to do this without a calculator, then you can't kind of like check the answer. You got to be a little more sure. And the idea was that when we said we were less than ±3, we basically ended up with numbers that would not make sense. You say, well, how am I supposed to know that? I'm showing you some of these special cases, so be aware of it. Because if I go less than plus n minus -3, then I journey down here, you can't plug in -10 because you're going to end up getting like the square root of a negative number. Okay, so we realize that if you get a plus or minus, you also switch the sign. Or in this case, maybe I should say you create that opposite sign. The range. It's a graphing thing. If I ask you to find the range, you're going to be able to use your calculator. I'm going to skip wheeling over the dinosaur, but if you want to type this in your calculator, again, it's not a bad idea. Again, it's not a bad idea because actually what you get on your calculator, I think, I don't know about yours. Okay, what you get on your calculator, I don't want to say it's wrong, but you need to understand that it has to be interpreted. It seems like it's sort of this little half circle, but it's like floating above the x-axis. And what's happening here is the calculator is having trouble with the algorithm. The algorithm is to plug in x values and plot the y values. It's having trouble plugging in like the last x value. It's having trouble plugging in 3. What I'm getting at is that the graph should connect the whole way to 3 and -3, because 3 and -3, when plugged in, give you a y value, 0. And the calculator sometimes has trouble with half circles. Okay, so your range is going to definitely get the whole way to 0 and get the whole way up to 3. The range is between 0 and 3. And by the way, it also supports the domain, okay, because my domain is between -3 and +3, and so is this circle. So I guess we can check it here because we're talking about it. Now, I went over 3 problems as best I could that kind of showed you different things. We got a denominator, we got a square root. You're going to see some of those in the assignment. Also, you're going to see some other functions. So mess around with them. Do the domain without a calculator. Use a calculator for the range, and maybe just be aware. If you're able to, which I hope you are, that's my little code for we're going to look in the book. So if you're able to, I encourage you to look on page 13. page 13. If for some reason you can't look at page 13, maybe just make note and look back at it sometime soon. We've got what's commonly called the power functions. Now, I don't know if you need to write this down. I mean, if you're asking, I don't think you do, unless there's something that really catches your attention as new. But notice where it is in your book and notice the graphs. Just kind of want to quickly go over the first row. You should know those. That's my code for, like, without a calculator. You should be able to draw something of the form y equals mx. A parabola, something that's quadratic. And then a cubic. Now, have you seen the cubic? Probably seen it. Make sure you're comfortable with it. That's the cubic function. That's row 1. Row 2. These shouldn't surprise you, but maybe a calculator helps you. Number 1 is a rational equation. We did a tricky rational equation. It had asymptotes, all kinds of goodies. So that's like a basic rational equation. The middle one is a radical equation. It's an even radical, normally called the square root. Okay, the square root graph compared with the cube root graph. Okay, the cube root graph is able to use negatives. Now, if you needed a calculator, you could have it, but it shouldn't be the first time that you've seen those graphs. The bottom row, they're just kind of like special power functions. Okay, we get some exponents going around, a rational exponent. A rational exponent is a fraction exponent. Okay? A calculator would be fine. I mean, I would probably even use a calculator to just double check what's going on with those. Power functions. Down below, we have a little statement here about even and odd. Look at it. Just kind of look at the yellow box, even and odd. After you look at that yellow box, which is maybe a little confusing, it's kind of got some notation with negative x, flip the page to page 14. It makes a little more sense when you read the 3 paragraphs at the top. Take a look at those 3 paragraphs at the top. Now the figures, which are basically like the drawings, the figures in the margin, they're worth looking at. Take a look at the figures. Okay, and now what I'd like to do, does that sound a little better? What I'd like to do is elaborate on this a little bit. You read it, you looked at some stuff. I'm actually going to show you some of the same things, but just try to simplify it and make sure that we get it. So when it comes to even and odd functions, they're like special. Okay, by the way, not every function is even or odd, but if it's even or odd, it's special. And so we've got this idea that says, and I'd like you to try to understand this. This is kind of a little fancy, but it says if you plug in negative x, maybe another way to say it is if you go to negative x, that would be the same thing. That would be the same y value as positive x. Remember, f of x is a y value. So this is saying 2 things. That's why it's pretty powerful. It's saying if I have a negative x or a positive x, either way, going to give me the same y value. And if that's true, then you have an even function. That's kind of the fancy math way to say it, like with the whole f of x thing. Here's a little more of a visual way to say it. Y equals x squared, pretty popular even function. The exponents are all even. There's points on this function. These points have x and y values. So look what these x and y values are saying. The same thing. They're saying if I go to negative x, if I go to positive x, you get the same y value. Okay, now, you kind of should be looking at saying, yeah, I mean, of course. Well, that's what makes it even. It's not that hard. It's just always true. It's always true. Line of symmetry. Line of symmetry. I can't write sideways. Maybe you want to do that. But the line of symmetry is always the y-axis on an even function. Let me just put one more quick thing on here. It was in your book, so I hope you saw it. AB, guaranteed to have negative AB. So if you have AB, you got to have negative AB. And that is an even function. How about if we plug in negative x? Notice that the whole parameter behind this is that we're plugging in a negative x, or maybe we should say the opposite of x. So if I plug in the opposite of x, and I get the opposite y value, I get the opposite f of x. So if plugging in the opposite of x produces the opposite of f of x, in other words, the opposite of the y value, then you have an odd function. You have an odd function. Okay, and visual, a lot of people are visual, not everybody, but visual for an odd function like y equals x cubed. Y equals x cubed is odd. All exponents are odd. And we have this opposite stuff. Now, listen, there's different points on here. How about the point 2, 8? 2, 8. Well, if I would go to the opposite x value, watch how this works. If you go to the opposite of 2, well, guaranteed you're going to have the opposite y value. And by the way, if you cube negative 2, you get negative 8. Okay, so it's working out algebraically also. AB, AB, opposite of AB. Excuse me, opposite of A, opposite of B. So AB, opposite of A, opposite of B. And all I'm kind of saying is that this is always going to happen in an odd function. POS, point of symmetry. Point of symmetry. Points of symmetry are a little harder because they actually involve two lines of symmetry, but it always is the vertical and horizontal. I like to think of it as folding. If you fold the graph over the horizontal line and then you fold the graph over the vertical line, it will fold on top of itself. It'll fold on top of itself. But a point of symmetry is two folds. Fold down, fold over. Okay, all odd functions have the origin as the point of symmetry. try something. I've kind of been doing most of the talking. And this is a little bit of like what you see in the assignment. So kind of getting you to do some of this thinking now. So even or odd, and why? Even or odd, and why? Now, just to make sure that everybody kind of realizes, because your neighbor is probably kind of thinking the same thing. Okay, so how do I do it? Well, I gave you some information. Okay, now some of this might be review. It's all algebra, so it's not like it's brand new, but I gave you some information. I'm trying to see if you can apply it. And just to let you know, there's more than one way to do it. Like I gave you a lot of information. I don't want to say too much, but there's different ways that you could say yes or no, or you could say even or odd. So which way, what are you doing? What's kind of your instinct here? Again, there are different ways to do this. If you're thinking something, great, go for it. Okay, hope it's a good way, because there's not just one way. Now, you guys, you're pretty normal, okay? Some of you have an answer, maybe kind of like with a question mark. Maybe you are trying to do something that's over here. Hey, this is a little fancy. Like, how do you actually do this? Okay, so I just wanted to give you a chance to try instead of just maybe waiting for me. Now, I hope it's okay me asking Haley, you drew a sketch of the first one. What'd you do with it? What'd you do with the sketch? What did it say to you? Why?
I mean, this was after the exponents, but I'm pretty sure I was wrong.
Wait, what was about the exponents? Okay, hey, you're not wrong. This is a little bit of a different method. So now I said something verbally, you might have heard me say that all the exponents are even. So that's an exponent that's even. Now we got to be careful about this because, well, when we say the exponents, we're talking about the exponents on x. There would be an x to the 0 right there, which also fits with that pattern that all the exponents are even. So it's not wrong. You could look at the exponents. That only works for polynomials. This is not a polynomial, so I can't look at the exponents, but it works there. Emma, you said even. Is it all right if I ask why? Like, what were you thinking? Okay, kind of the same idea. Anything I saw some of you using your calculator, maybe the sketch. Let's talk about the sketch if you think you know what to do with the sketch. Bryce?
I said it had a line of symmetry across the y-axis.
That's always the case. If you have a line of symmetry with the y-axis, it's going to be even. Now, I'm not sure I noticed this. I don't want to miss somebody, though, if you were trying this, because it's a little mathy. It's like trying to use this statement. The statement says plug in the opposite of x. Now, if you plug in the opposite of x, you get the opposite of x squared. What are you going to do with that? Well, you can perform the opposite of x squared, and what you discover is that it's going to still come out to be x squared. In other words, it's going to come out to be the same thing. Sometimes people look at that and say, well, you didn't really do anything. But we realize that if you square the opposite of x, because of even and odd properties, you get the same thing. I plug in the opposite of x, I get the same thing. You get f of x. F of x, in other words, the original equation. How about the sine of x? The sine of x. I saw some of you graphed it. That's fine. We're actually going to talk about the trig functions. Spend like a couple days talking about them. But the sine of x hasn't changed since last year. It's still, okay, it's still going to be that wave. But a couple things, especially if you didn't use your calculator, how about that whole radians and degrees thing? Actually, calculus is always done in radians. I didn't get to tell you that. We're going to focus on that in a couple days. But radians, zoom trig. This might be the one thing that would be good to remember, because zoom trig kind of resets your window. It resets it so that the sine wave kind of fits into it. So I typed in the sine of x, I changed or made sure I was in radians, and zoom trig gives you a nice window. If you go to an x value, okay, now this is kind of like, well, which x value do I go to? Okay, well, I don't know, maybe I'll go to this one up here, 1.57. It's pi over 2. I'm just saying, if you pick an x value, then you can go look for a related x value, okay? The related x value would be the one that is the opposite. So I picked an x value, a, but now I'm going to go to the opposite of a. But what am I looking for? What am I expecting might happen? It's the y value. I'm expecting or wondering if the y value will also be the opposite. Now, it's kind of hard to make a proof based on one point. Okay, I picked one point and found out that it works. When I go to the opposite, I get the opposite y value. But it is using this concept of the opposite of x will produce the opposite of f of x. In other words, the negative x value will give you the negative y value. I'm trying to help you see that we can still use that strategy as a proof to be able to say, I guess we should have said this is even, but to be able to say this one's odd. You know, and how would you show that? How would you show that? By giving the point. So I'm giving the point that I picked. And again, that point, I don't want you to think I arbitrarily picked it. I kind of went to that point because it was easy to notice. It was at the top of that sine wave. You could also, and it's a visual proof, but you could also say that this graph has point symmetry. It has point symmetry with 0, 0. And so that could be a reason. When you do your assignment, if it says to, explain why, these reasons would be okay. Up here, my reason is a little bit more of some math induction where I actually plugged in. Okay, down here, my reasons are a little bit more visual where I'm like looking at the graph. Still trying to get used here. Let me show you just one more thing. I don't know if you need to write it down, but let me show it to you because I don't want you to leave thinking that everything is even or odd. Had I said, let's look at cosine. Let's look at cosine. You see a graph, it just doesn't seem to fit. It doesn't seem to fit. Actually, or does it? I was trying to pick a graph that maybe was not even or odd, but just visually, it looks like that this has y-axis symmetry. So I guess that one would be even. There are some graphs that because of their position, they are not going to have either symmetry. Okay, that's not a good example because that has symmetry. Okay. We have a little bit more to talk about tomorrow with this lesson. Okay. So keep working on lesson 1.4 and 1.1. Because actually after tomorrow, we'll be done with this one. Okay. Your first assignment, it's due next week. Maybe you looked ahead or you can see that it's Wednesday. So again, keep at it.